In this video, we're going to look just at example 5 from your A-16 notes, and I'm actually going to show you two different ways to do this problem. So one way that you can do it is, if you go back to the rules here, the rules said, I'm going to get rid of all this messiness here, that the first thing that you should do is to isolate the exponential expression. So in this particular problem, if you want to do that, you'll notice that this needs to be isolated. I probably should have put a dot here for multiplication rather than the x. A little confusing with the x up here. That the exponential here needs to be isolated, and the same thing here. All right. So what you could do for this one is you could divide both sides by 2 to the x if you want to. And so that's going to give you 2 times, and then notice that when I divide these two powers with this, I have 3 to the x over 2 to the x, so I could rewrite that as 3 halves to the x is equal to, and then those cancel and I get 5. So now if I divide both sides by 2, this becomes the function 3 over 2 to the x is equal to 5 halves. Okay, so that's my equation that I'm trying to solve. So now what I can do is, just like a previous problem, I can take the natural log of both sides. So I get the natural log of 3 halves squared is, natural log of 3 halves to the x equals the natural log of 5 halves. And then what I can do is bring this x in front. And so I end up with, if I come up here, x times the natural log of 3 halves is equal to the natural log of 5 halves. And then dividing both sides by the natural log of 3 halves, that's what I end up with. So x is equal to the natural log of 5 halves divided by the natural log of 3 halves. Now, I'll point out to you at this point for this problem that you could say, well, in the numerator I have the log of a quotient, and so I can rewrite that as the difference of the logs. So ln 5 minus ln 2. And then same thing in the denominator, I have the log of a quotient, so I can rewrite it as ln 3 minus ln 2. Okay, and that would be perfectly acceptable. Now, another way that you could do this problem, though, is that you could, even the way that it is right here, without isolating the exponential part, all right, as it said to do back here, you can actually get away with not isolating the exponential and just at this point taking the natural log of both sides. So you get the natural log of 2 times 3 to the x is equal to the natural log of 5 times 2 to the x. And so what you have here, you'll notice, is the log of a product. And the same thing here, log of a product. So we know that the log of a product turns into the sum of the logs. So this is really ln of 2 plus ln of 3 to the x equals ln of 5 plus ln of 2 to the x. Now at this point, what you generally do is you get all the terms that have x's in them on one side and everything else on the other side. So if I subtract ln of 2x from both sides, or 2 to the x power, so that's going to move all of the x's to this side. Now if I want to get rid of the ln 2 on this side, I can just subtract ln 2. And so I end up with, these go away, so I end up with ln of 3 to the x minus ln of 2 to the x is equal to, these go away and I just get ln 5. Now at this point, and maybe we could have done it earlier, you might notice that, hey, I can bring the x out in front. So this is going to turn into x times ln 3 minus x times ln 2 is equal to ln 5. And then notice that both of those terms have an x in them. So what I can do is, sorry, on this side I forgot that this has minus ln 2 on it also. And so now what I can do is I can factor out the x. So I get x times the quantity ln 3 minus ln 2 is equal to ln 5 minus ln 2. Then I can divide both sides by this entire quantity, ln 3 minus ln 2. And I end up with x is equal to ln 5 minus ln 2 divided by ln 3 minus ln 2. Right, and you'll notice that that's the same as what we got here. So ln 5 minus ln 2, let me make this a little bit smaller. We can see that right here, ln 5 minus ln 2 in the top, and then ln 3 minus ln 2 in the denominator. So check, but works both ways.